Hello and welcome back to another digital circuit analysis. Today we are going to review this logic gate circuit and determine the output Z and not Z waveforms in relation to the input A and B pulse trains. As you can see here, the pulse trains A and B have two levels, high and low. In digital systems, high is considered logic 1 and low is considered logic 0. Now, in order to determine the output level of each gate at any given time, we need to look at the inputs A and B respect to each other at every time intervals. Therefore, we call the time intervals as a T0 to T8, so we can determine the output of each gate during the T0 to T8 intervals. As you probably already know, the gate number 1 is AND gate and has a following truth table. The AND gate has a high or logic 1 output only when its both inputs are logic 1. This is why the AND gate is called all or nothing gate. The gate number 2 and 3 are OR gates. You can see the OR gate truth table here. The OR gate is called any or all, which means the output is high when any or all of the inputs are high. As you can see here, I have assigned the letter X to the output of the gate number 1 and letter Y to the output of the gate number 2. And now our goal is to analyze their output during each time interval. Before we continue, I will appreciate if you take a moment and subscribe to the channel. Your support will help this channel to grow and encourage me to create more content. Thank you, and now back to the input pulse trains and analyze the outputs. During the interval T0, the input A is 1 and B is 0. So the output X will be logic 0 and Y will be logic 1. This is because the gate number 1 is AND and the gate number 2 is OR. At the same time, since the gate number 3 is an OR gate, then this will lead to have a logic 1 at output Z. During the time interval T1, the input A is 1 and B is also 1. So the output X will be logic 1 and Y will be logic 1. Therefore, we will have a logic 1 at output Z as well. At interval T2, A is 0 and B is 1, so the output X will be logic 0 and output Y will be logic 1. And again, we will have a logic 1 at output Z. During the time interval T3, the input A is 1 and B is 0. So the output X will be logic 0 and Y will be logic 1. Therefore, again, we will have a logic 1 at Z. At T4, both inputs A and B are 0, so both outputs X and Y will be logic 0. This will lead to have a logic 0 at Z. During the interval T5, both inputs A and B are logic 1. Then both outputs X and Y as well as output Z will be logic 1. At the time interval T6, both inputs A and B are 0. Therefore, both outputs X and Y as well as output Z will be logic 0. During the time interval T7, the input A is 1 and B is 0, so the output X will be logic 0 and output Y will be logic 1. As the result, we will have a logic 1 at output Z. And finally, at T8, both inputs A and B are logic 1. Then both outputs X and Y as well as Z will be logic 1. Let me draw the waveforms for X, Y, and Z. Now, since we determined the output Z waveform, then not Z will be the inverse of the Z waveform. So we will get the following result. I hope you enjoyed watching this video. I also have other videos in reviewing digital logic circuits, which I will put the playlist link under the video description. Please like, subscribe, and share your thoughts under the comments. Thank you for your support and see you at the next video.